Hello guys, welcome to this lecture, and this lecture is going to be on enumerators, enum and type def, the two data types, and then followed by that we will just start to see conditional statements followed by switch. Then we will also see loops, and also for each and everything we will be seeing few problems also, very small problems we will be seeing for each and every topic also. So we will just start with enumerator actually. So why enumerator is required? What is the need for enumerator? What enumerator is going to be used for? All these things we will just see shortly. But before that, I would tell you that in the previous videos, I have clearly spoken about the classification of data types actually. In that classification video, if you go and see, I think data types have been divided into three classification, like primitive data type, user defined data type and derived data type. And under user defined data type we have three data types called enum, structure, union. So this enum and type def actually comes under user defined data type. So enum and type def are coming under the classification called as user defined data types. Okay, so now we will see what is the exact need for these two things. Here, if you see here, I have taken certain list of data like departments. Under departments we have taken CS, ECE, IT, civil classification. Here, coming to menu, in the file you will have new, open, save. This any software you can able to see. For example, here file is there, in that new, open, save, all these options will be set. So I have taken example of this. Then coming to days, you have classification from Monday to Sunday. Card shapes, like if you know to play cards, then you have four shapes available, and the four shapes are club, spade, diamond and heart. So coming to feedback, a concept called feedback, you used to either say poor feedback, satisfactory, good, excellent, as you give to me. Okay, so these are few things that I have taken. Okay, what is the relationship between these classification enumerator? We are not going to see type def now, we will be seeing it later in the next, as a next concept we will be seeing type def, but now we will see enumerator. It's a relationship between enumerator and these classification actually. See, this classification, if you tell CS is actually a collection of characters. C is one character, S is character. So this can be called as collection of character. Collection of character can be termed as strings. It can be termed as strings or collection of characters. So coming to a string, you know very well that each and every character takes 1 byte of data. So if there are 2 characters, then 2 byte of data. If totally 5 characters are there, then 5 byte of data. So what I am trying to say is that I don't want to waste that much memory. Instead of not wasting that much memory, what I can do is that I can take this CS as a constant, like a variable, and I can give code to each and every constant. For example, CS can be given a code like 1, EC can be given 2, then IT can be given with 3, and civil can be given with a code called 4. Any code you can give, it is up to you. Either you can, but number, the code is going to be there in number, data type called number. So by giving codes to each and every every term like this, you will be reducing a memory. Okay, you're going to reduce a memory. For anything, only constant only integer you're storing. Whatever the length of the string might be, even the length of the string is 25 characters, even though we are going to assign only one number to it. Automatically a number means at maximum integer value means you will be assigning it a 4 byte of data. So you will save data as well as, and also this will make the program look very readable. We'll see how this is going to make it readable. Okay, so first of all, I'll just go and let me give you a small demo on this. There's something called as const. Const means it tells that we are going to convert a string into a constant followed by integer. Why it is called as constant? Because you are converting CS into a constant, and also you are assigning a code which is an integer. That is why you are taking const int. And what you are going to do, constant, and you are going to take CS and you are going to assign a code called 1. Similarly, what you're going to do, const, and you're going to int, and you will be writing, for example, ECE is equal to 2. Then const, you will be writing IT is equal to 3. And finally, const int civil is equal to 4. So these four constants we have taken and codes we have assigned. How to use these things? For example, I can take integer, for example, I can take integer yes, and I can assign cs. I can assign cs to it. And after assigning cs, what I can say, actually, I can just print s. Let me print s. Okay, so what cs is having? Cs is having an integer value, so use %d to print it. %d comma yes. So let us compile and check what this is going to give us, what answer this is going to give us. It's giving me 1 because cs is assigned with 1, the code called 1, so it is printing me 1. So now if I just directly print cs, what will happen? Again, this will also give you the value called 1 only. So instead of using cs as a string, hereafter you can use it as a constant if you want to do comparisons, if you want to do any operation, any conditions, if you want to check any conditions, then you can go with the codes. If s is equal to cs, what will happen? S also will store 1, cs also will store 1. Then automatically, if cs is equal to cs, s means the department. Okay, fine. So now one more thing that I wanted to show you is that instead of giving the constant code like this, I can cluster it and I can give it as a single statement. For example, I can give enum followed by, you can give a name to it. What is this? This is department. So let me give a name to this enum department, and open a close curly braces and close it also. And inside this set of bracket, what you can do is you can just simply write all this constants, cs comma ece comma it comma civil. Yes, so now you can get rid of these things. Now what happens is, you need not to give any code. Automatically cs is assigned with 0, ec is assigned with 1, it is assigned with 2, and civil is assigned with 3, so that we can just check whether it is true, whatever I'm telling is true or not. Is %d followed by 5%, s4 is enough, right? Comma cs. Okay, coming to cs comma ece comma it comma civil. So we'll check what it is going to print us. Okay, so we'll just again go with the compilation and execution. So compilation successful, execution. You can able to see 0 1 2 3. So cs is automatically assigned with 0, ec is automatically assigned with 1, it is automatically assigned with 2 and 3. Can you change this? Yes, you can change it. How it can change is, I can give cs is equal to 2. So I can just simply give cs is equal to, and I can stop. Now what will happen is that this cs equal to 2 becomes a starting point. So hereafter this will not be, ec will not be 1, it will not be 2, civil will not be 3. You can see in the tooltip itself, and cs is 2, ec will be 3, it is going to be 4, and civil is going to be 5. Yes, so this becomes a starting point of the enumerator, and this is followed by 3 4 5. So you can again, I can just compile it and then can give you the output 2 3 4 5 as we expected. Can you able to give a different thing? Yeah, you can also give a different one. Now if this is 2 and this is given a 6, and what this will be, continuation, whatever the last enumerator value that they are given, continuates. If it is 6, go to 7, go to 8. Yes, so I can just here again just compile and just show you again the output. Yes, 2 and 6, wherever you left you can continue 7 8. Yes, so this is it for enumerator actually. And this enumerator, when you can use this actually whenever you have any classification, and don't take those classification as a string. Instead of taking it as a string, take it as a constant and use this to classify it. Okay, whenever you have a classifications like department, menus, weeks, then all these classifications can be written taken as an enumerator, and then it can be sent for process. Yes, fine. So now what I will do is, next I will just go for type def. The next thing that we will be seeing is type def. What for is type def? Type def is also a part of user defined data type. Why this is called as user defined data type, we will see now. Okay, so for example, let me show you a declaration int m1 comma m2 comma m3 comma for example r1 r2 r3. Yes, I have already insisted you not to use variables like this, because this will lead to confusion later when the program keeps on growing. When the lines of code is very large, then this kind of variable naming the variables with these names is going to confuse yourself. So here what happens is that readability issue is coming. Readability issue, when the program becomes very big, the readability issue, you might confuse lot. At last you might forget for which purpose you used m1 m2 m3, for what purpose this variable m1 m2 is 3 m2 m3 is given. So this is getting a readability issue. So to overcome that readability issue, only what we are doing is we are introducing a type def. What we can do now is that, let me take that m1 m2 m3 are three variables made for marks. We are having 3 marks, and r1 r2 r3 corresponds to the roll number of 3 students. This is what it means. m1 m2 m3 are for the 3 marks of a student, 3 subject marks, and r1 r2 r3 are the roll number of 3 students, for example. So what I can do is, actually I can write a type def. And I can say that instead of integer, hereafter you can use marks also. You are giving a alias name. Instead of int, integer can also be given, but instead of int, if you give marks, marks will be automatically translated into integer by the time of compilation. So now int also is int marks, both are same. We are giving same name to the same keyword, so both are going to do the same job. Again, what I'm going to do is, not only one more name I can give multiple names to the same keyword. So the integer keyword is also given with another number called roll number. Yes, so now let me come to the main function. Now what I can do is that, in order to overcome the readability issue, what I will do is just I'll give you the alternate declaration. So hereafter, instead of saying int m1, what you do is mark. Okay, marks m1 m2 m3 followed by roll number r1 r2 r3. Now you might understand easily that, okay, m1 m2 m3 are marks, and r1 r2 r3 are roll number of the students. So by seeing this, easily you will be able to identify. Now the readability issue is solved by using this type def. Okay, so what I will do is that I'll just assign m1 m2 m3 with the 3 values, for example 45, and m2 with 67, and m3 with 76, 3 values. And now what I will do is that I will use printf statement to just print the 3 numbers. So %d, 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 comma m1 m2 and m3. So we will just see whether it is in the form of integers or not. Yes, they are in the form of integer only. So marks means integer. Roll number also is referring to integer. So what happens automatically, some readability is there in this. So readability issue can be solved by using this. Yes. Okay, for this reason we are using type def. Okay, fine. So this can not only is recommended for integer, any data type you can use this. Fine. Okay, fine. So next, from here what we will do is we will start with conditional statements. We'll go into conditional statements. Very important part of for any beginner is this conditional statement part. Okay, so we will just start with conditional statements. So inside conditional statement, first of all, we will see about the if conditional statement, and then we will move forward. Okay, I'll just give you the general structure of this, okay, protocol of it. Okay, so I'll just give you if is a keyword followed by a parenthesis. Inside this, you need to give a condition. We will see about how to give a conditional, but inside this parenthesis, you should have mentioned, you should write a condition, then followed by a open and close curly braces, which will decide that this is a block, and whatever line you execute is inside this if block. Okay, so here you can write, you can have any number of lines, any instructions you can write, any instruction, and any number of any line, any number of lines of instruction you can provide, and followed by a else part, and inside this else part you can have any instruction as as like if condition. Any number of instruction can be provided here in this part also. And generally this else part is a optional part. You can give or you can ignore also. You can use it or you can ignore it. It's an optional part. So if is enough. If no else is required, then you can ignore it. But without your if, your else cannot work. If is not optional part, if is a compulsory part, where else is an optional part. So without if, else cannot work, but without else, if can work. Okay, so now what I will do is I'll just take this condition, and I'll tell you how to write a condition. A condition can be written using relational operator. So here we will see about what is a relational operator, what are all the operators available. So using relational operator only, this condition can be written. Okay, so first of all we will see these conditions and then we will go. Okay, what are all relational operators we have? Okay, so relational operators. So what are all the relational operators we have is we have less than, okay, we have greater than, we have less than equal to, we have greater than equal to, we have equal to, we have not equal to. So these are the relational operators that we have. Okay, so now what will happen is that using these see, generally we are having like truthness. What is truthness? If this condition, whatever you are providing in this if statement, if it is true, then this part of lines will be executed. And suppose the condition which you are providing here, if it is false, then the part which is written inside the else will be executed. What is true or false? I'll tell you now. What is true or false is, true means it is equal to 0. Here in C, a true means it is equal to 0, and false means it is equal to any non-zero number other than 0. All the other numbers are considered to be, sorry, not true. I think false is 0. Okay, sorry, I just inverted and just told you. False means it is equal to 0, and what is true? Actually, true means it is equal to any number other than 0, not 1. Usually people say 1. No, even 2 is also called as true, 3 is also called as true. So other than 0, any positive, any other number, okay, apart from 0, any non-negative number, not non-negative, non-zero number. Okay, so any non-zero number are considered to be a true value, non-zero number. Okay, fine. So let me again come back to relational operator. What this relational operators will do? These operator requires two operands actually. For example, I'll just tell you one scenario. 10 is greater than 20. Is it a true statement? 10 greater than 20? No, 10 is not greater than 20. So this will automatically return you 0, which will return you this relational operator will return you 0, because this is a false statement. Suppose if I change it to less than symbol, what it means? It is a true statement. 10 is less than 20. So automatically your relational operator will send you 1. So what is the work of your relational operator? It will check for the condition and it will return either 1 or 0 based on the truthness of the statement that we are providing. If the truthness of the program is true, then I return 1. The relational operator returns 1. If it is false, then the relational operator returns you with 0. Yes. So the next thing that what we will see is that we will see a few problems in order to make you understand about this if conditional and all. So we'll just go to the next. We will just find a maximum of 2 numbers. We'll just find the maximum of 2 numbers. Okay, fine. So now if you see, I'll just, to find the maximum of 2 number, you need first of all input 2 numbers you require. So I will take int num1 comma num2, 2 integer values I will be taking. And I'm going to store anything? No other variables required, because I'm not going to I'm not going to store anything. I'm just going to print that whichever element is the maximum element. How I can do? I can take a if condition, because here we will use a conditional statement if. What is a condition? How will you write? Using a relational operator. How you can say that either num1 or num2 is greater? If num1 is greater than num2, I will say num1. If num2 is greater than num1, I will say num2. So I can write that if num1 is greater than num2, it will return you 1. And if the condition is returning as true or 1, what it will happen? All the lines of code which is written inside this block will be executed. So if num1 is a greater, then I will enter into this block and I will be printing that percentage d is the maximum number. It's a maximum number. Else what you will do? Else I will just tell, if suppose if number 1 is not greater than number 2, definitely automatically number 2 will be the greater. So if this condition is not true, what you do? You just print that your see here, percentage d is the maximum number. Instead of percentage d, you have to give a variable, right? What is the variable? Num1 is the maximum element, so you can give num1. Similarly here, if you are coming, percentage d is the maximum element, the same sentence, but what is, instead of percentage d, what you will give? Instead of percentage d, you will give num2, because if num1 is not greater, then num2 becomes a greater element. Okay, here still if you see, I have not received any input, so I will use scanf and I will receive 2 inputs, scanf percentage d comma ampersand num1 and comma ampersand num2. Yes. So what I will do is just I'll go for compilation. So terminal, so I'll just go for compilation. So compilation is here, and then comes it is waiting for me to enter input. What I can give? 20 and 10. Yes, 20 and 10 means 20 is the greater element, so it is giving 20 is the maximum element. Let me give 23 and 67, which is a greater 67, so it is giving me 67 is a maximum number. Perfect, it is working perfectly, right? Okay, fine. So now next thing what we will see is, the next question is, we will see checking whether a given number is a positive number or not. We will see question, a simple question like checking whether a given number is a positive. So check if a given number is positive or negative. Very simple. What it is? How will you say that a number is positive? If it is greater than or equal to 0, I say it is a positive. If it is less than 0, then it is automatically a negative number. This is how I will be telling you. So I think for this we can use if conditional statement for solving this problem. Yeah, so we will see about this same question, checking whether a given number is a positive or negative. Fine. So what we can say is that if the number is greater than, as we say that, as I already say, it is greater than 0, I will say greater than or equal to 0, I say it is a positive. Else I will say that it is a negative number. So what I can do is, first of all, I can take a variable called num, and using scanf I can receive an input for this variable percentage d comma ampersand and num, and then I can check if num, the variable num, if it is greater than or equal to 0, if it is holding the value greater than or equal to 0, then what I can do, if this condition is fine, if this condition is true, it will return 1. If 1 is written, then I will enter into this if condition block, and what I can print is, I can print that this is a positive number. It is a It is a positive number. Fine. Else, suppose if this condition is not true, what I have to say, I will tell you that it is a positive, it is not a positive number. It is not a positive number. Yes, that's it. So we can just execute and check whether this is working or not. So let me give first of all 34. Yes, it is a positive number. Let me give -9. It is not a positive number, it's a negative number. It means that it is a negative number. Okay, so this is how you find the difference between a positive and a negative number. Then we will go with checking whether a given number is odd or even. Okay, these are all basic questions because we have planned this course for beginners too, so everybody have to take this course. So I get a feedback from people, students, that it is very basic. Yeah, I got a lot of feedback from the students that it is very basic. Yes, this is a course which is extensively made for all kind of people. That is why the course is named from scratch to advanced. Okay, so automatically we will definitely go to the advanced concepts also. Okay, so until that, you have patience, be calm, watch all the videos, because you might think this is a very basic thing, but this is the flow that we are going to follow in the remaining videos. I might use certain terminologies, I might explain you what is this terminology, and later part I will be just using the terminology. I will not explain again, we have no time to explain it again. So that time you have to again come back to this video, then only you will understand that video. So instead of that, please now itself be calm, watch all these videos one by one, and we will just enter into advanced concepts also. Yeah, fine, thank you. So the next thing is checking whether a given number is a odd or even. So check if a given number is odd or even. How we are going to do this? Odd or even? How will you check? How will I check? Yes, first one is that if a number is completely divisible by 2, if a number is, we are able to split a number equally into 2 parts, what will happen? Then it is called as even number. For example, numbers like 4, 6, 8, 10, these are all divisible by 2. If a number is divisible by 2, then it is called as even number. If it is not divisible by 2, then they are called as odd number. How will I check whether a number is divisible by a particular number like 2 or any number k? That we will see now. For example, we'll have the same skeleton. We'll have the same skeleton. Yes, we have declared a variable called num, and we have received an integer number from user, and now what we have to do is we have to check whether it is divisible. Yesterday itself I told you, we have seen not in the yesterday itself we have seen a video in which I have explained you about the mod operator. What is the work of mod operator? It will give you reminder. For example, if 12 is divided by 3, then the quotient is different, reminder is different. What is a quotient? Quotient is 4. What is a reminder? If you divide 12 by 3, it is equally divided into 4, and you get no reminder, so reminder will be automatically 0. So you can say that if the reminder is 0, then it is completely divisible. If the reminder is not equal to 0, then it is not divisible. So if you want to check whether a given number is divisible by a number, then you mod it. If the mod value, result value, is equal to 0, it is divisible, else it is not divisible. So what you can say is that if num mod 2, if it is equal to 0, what will happen? It means that it is an even number, because it is divisible only, you will get the remainder as 0. So if this condition is true, then you can write that that particular number is an even number. It's a even number. Suppose if this condition is not true, else what will happen? Else this is not odd, this is not even, this is an odd number, so write odd. Okay, so we will go with compilation and we will execute and we will check. Okay, so just I'll go with compilation, execution, it is just waiting. So I'll just give 12, it's a even number. I'll just go with 13, it's an odd number. Yes, fine. One more strategy also I will just teach you by using the bitwise operator. I think you have already seen the bitwise operator called AND, bitwise AND. For example, I will just show you the representation of 12 and 13. What is the representation of 12? The representation of 12 is 1 0. It is 10. Yes, right. It is 1100 is what the representation. So I'll take the 8-bit representation. So 4 zeros I will take, then followed by 1100. This is what a 8-bit representation of 12. I'll take also 13. 13 means it is 0 0 0 0, and it is 1 1 0 1. This is what the representation. So the first one is the representation of 12 and second one is the representation of 13. If you just observe, not only for these numbers, for all numbers, even number means the last low significant bit, LSB, low significant bit, will be 0. If it is an odd number, then this lowest significant bit will be always 1. This is true for all the odd numbers and all the even numbers. Okay, fine. So if I find whether the last bit is 0 or 1, then it is very easy for me to tell whether it is an odd number or even number. How to find whether the last bit is a 1 or 0? What I can do is that I can take only the binary representation of 1. What is a binary representation of 1? Only your last bit will be, the low significant bit will be 1. This is the bitwise representation of 1, binary representation of 1. So now what I'm telling is, if you bitwise and if you do a bitwise and between the numbers, what will happen? If the last lowest significant bit of the original number, like for example 13, if it is 1, what will happen? 1 and 1 will give you the resultant answer 1, because I know what is AND gate will do. If both are 1, the resultant bit also will be 1. So remaining all the part will be 0, because obviously the number 1 will be having all the remaining 7 bit as 0. So again you will be getting 7 zeros. So but the answer, what is the corresponding decimal representation of this? 1. Okay, so all the remaining 7 bits will be 0, so automatically the representation of this will be 1. So you take a number, you do bitwise AND with 1. If the resultant answer is 1, then it is an odd number, and if the resultant answer is 0, why it is 0? Because if you take this number, the last bit is 0, and 0 and 1 is made and gate, what will happen? 0 and 1 means it is 0, so this will become 0. So if it is an even number, then it becomes 0, and if it is an odd number, it becomes 1. So that also we can check once. Instead of saying this, what we can say is actually, if n is bitwise and 1, and the answer is if it is equal to 0, it is an even number. If the resultant is not n, it is num. Okay, so num bitwise and 1, if it is equal to 0, then it is an even number. Suppose if it is giving answer 1, then it is an odd number. That we have seen here, the explanations. Okay, so now we will just compile it and check whether this is okay, working perfect. So just we will give 12. 12 is giving you odd number. Well, is not odd. Is okay. We will just check. Okay, no issues. We'll check. Okay, we'll find. We'll debug it. If there is any issues, we can debug it. Okay, so we'll again just give 12 and check. It's again showing me odd. So shall we just print what is num mod 1 and num ampersand 1 and check num bitwise and 1. Okay, we will do a debugging process here. Whenever there is a mistake, you can just check what is happening. Okay, num bitwise and 1. We'll check what it is going to print, give us. Okay, we'll give a space also. So now we will just compile it, and let me check it again. By giving 12, it is giving you the answer 0. So what is the issue here? So num mod 1 is actually giving 0, and 0 equal to 0 we are checking here. Fine. So we will just give a bracket and check whether it is working. Okay, we'll just give a bracket and check whether working. Okay, what might happen is this 1 equal to 0. I think so. It is just executing. Okay, for x, we will just for some sake we will just check. Yes, now it is working perfectly. Okay, so that bracket was a big difference, but it makes a very big difference. Okay, so if you are not giving this bracket, then it is working wrongly, because I think this 1 equal to 1 is taking place. Okay, fine. So see, sometimes the compilers might work differently. Each and every versions of the compiler will work differently. Okay, this might be a problem in my compiler alone. You can check, verify once. If there is a problem for you also, you can just comment, give a comment here in the comment section. Then I'll just explain you the reason also. We will see the precedence which is working here also. Okay, fine. So we have seen checking a number is a positive or negative. Now we have seen whether it is odd or even. We have seen two methods of finding whether a given number is odd or even. Yes. So now the next thing that we will do is that we will slightly enter into logical operators. Okay, you might wonder why he started with if, then he went to relational. Yes, because inside if condition only I require condition. For condition only we are coming to relational operator. That is the reason why I'm placing relational operators inside if condition. Yes. Now, what is the necessity of logical operator? Why we require logical operator? We require logical operator when we are having two condition and when we want to combine the two condition. For example, I will tell you. Okay, there is a variable called n and the value is 20. You want to check whether this is in the range of 10 to 30. You want to find whether the given n is in the range of 10 to 30. Then what you have to say, first of all, it is 10 to 30 means definitely one possible way is n will be greater than 10 is a one condition. You cannot give like mathematically you give, right? For example, 10 is less than n less than 30. This way you cannot do. Okay, this way you cannot do. Okay, so there is no possibility of writing mathematical equation like this. So what you can do is, one condition is n have to be greater than or equal to 10. This is one condition. Next condition is it should be also less than or equal to 30. Then only it will be in the range of 10 to 30. So n should be also less than or equal to 30. And now you have two conditions. When two conditions are given, how to combine this? What is a connector? This connector is only going to be this logical operator. When two conditions are there using relational operator, in order to make a junction between these two conditions, we introduce logical operator. What are the logical operators available? Logical operators available are logical and, logical or, and logical not operator. So these are the three operators that is available here in logical. Okay, so whenever you use this whenever you join two conditional statement using a logical operator, then this entire condition, for example, what is the here I have to give logical and. What is logical and? Logical and means it is similar to AND gate only. What is AND gate will do? 0 and 0 means it is giving 0. 0 and 1 it will give you. For example, I will write 0 and 0 will give you 0. Okay, and 0 and 1 will give you 0, and 1 and 0 will also give you 0, and 1 and 1. So both the bit has to be 1. So both the left side condition as well as the right side condition, both has to be true. If both are true only, I can say that it is in the range of 10 to 30. Okay, so that we need to understand. Okay, so if the first bit is 0, second bit is 0, then it is 0. First bit 0, second bit 1, 0. First condition 1, second condition false, then 0. First condition true, second condition is also true, then only the resultant answer will be true. So this is called as a compound conditional statement. Okay, this is compound conditional statement because two conditional statements are merged together by using logical operator. So entirely this condition is called as compound conditional statement. Okay, for this reason only we are introducing logical operator. So this what we have wrote here is for the AND logical operator. Okay, for AND logical operator, this table you will follow. And for the logical OR operator, what you will follow? You will follow the OR gate. 0 or 0 is equal to 0. 0 or 1 is equal to 1. So what OR gate will do? If either one of the condition is true, then the resultant answer also will be thrown as true. So 1 or 0 also will be taken as 1, and 1 and 1 both are 1, then it will be taken as 1. This is what will happen in the OR condition statement or logical operator. Okay, so now what I will do is that we will just do one or two problems to understand the usage of logical operators. Okay, so first of all, just what we will do is, then I will later I'll just come to this not operator. What not will do, what not just generally what not will do, not will change 0 to 1 and it will change 1 to 0. It will reverse the bit. Okay, so what it has to do is that if you give 0, then it is converted to 1. When if you give 1, then it is converted to 0. That's it. So for this and or, if you see, you need two condition, but for not, what happens, only one condition is enough. That is why 0 means 1, 1 means 0. So this require two conditions, and or requires two conditions on the left and right side, but not will require only one condition. We will see the demo of this. Okay, for example, now we will see, we are going to see a problem. For example, okay, a scenario. Okay, what scenario we will be seeing is these type def and all I'll remove. Okay, what we can do is that we can say that there is a employee who is working in a company, and we will take a train time, like train clock, like 24-hour clock. Okay, we will take a 24-hour clock. So in a 24-hour clock, if you see, it starts from 0 and it goes up to, for example, 24. It means I will come to 23 hours. So 0 to 23 hours. So what I will tell you is that I'm just splitting it into 9 part actually. So 8 parts, 8 or 9 parts, for example. So 0 to 9 I will take it as a 1 part. 3 part I will split 8 parts. So then 9 to 18 I will take it as a 1 part. Then from 18 to 23 it is another part. So I'm dividing this into 0 to 9, it is 1 part of the day, and 9 to 18 it is the next part of the day, next part of the same day, and 18 to 23 is the next part of the same day. So you're having 3 parts. And what I'm telling you is that an employee will be working from 9 o'clock to 18. 18 means 6 o'clock in the evening. So from 9 o'clock to 18 it is a working time for him. From 0 to 9 up to 9, it is not equal to 9. Up to 9 it is not a working hour, it's a free hour, leisure period. And after 18 also it is a leisure period. So 9 to 18 only he is working. So what you have to find is that you have to find, they will give you the hour, and you have to check whether that hour is a leisure hour for an employee or a working hour for the employee. It will be given as an integer like 9, 10, 11 or 1, 2, 3. So first of all, I will just write int hour, and I'll receive an input from users by writing scan of percentage d comma ampersand hour. So now what will happen after receiving hour? I need to check whether it's a working hour. Working hour means it should be greater than 9 and it should be less than 18, the similar to the range we see. So if it has to check the range, what I need to do, if my hour has to be greater than 9, greater than or equal to 9, because from 9 o'clock the work starts. It should be greater than or equal to 9, and at the same time now comes a compound conditional statement, logical operator and, because both the condition has to be true. Hour greater than or equal to 9 also have to be true, and hour less than or equal to 18 have to be also true. So when both has to be true, then I come to this condition. So when this condition is true, what I need to print, it is a working hour. It is a working hour. Suppose if this condition is not true, what it means actually, it is a leisure period. It's a free hour for him. Okay, so it's a leisure hour. Okay, this is what we are going to do. So just we will compile it and we'll execute this. So let me give, for example, 3. 3 is not a working hour. 3 means 3 o'clock is a leisure hour. He will be sleeping or doing something. So leisure hour. So I have to give, for example, 14. 14 is 2 o'clock. 2 o'clock is a working hour. So it is telling me that it is a working hour. So it's working properly. So initially we started writing only one condition. Now we start writing two condition, and we are merging it by using a logical operator. We are going one step every time. Okay. Fine. So now what is the next thing that we will be seeing is that we will be checking whether if a person is a young or old person. How will you check whether a person is a young or old person? I'm telling that if a person's age is between 12, in the range of 12 and 50, 50, 50, 50, then I say that person is a young person, or else he's not young. That's it. I'm not telling it's old. He's not young. Okay, I have to say that whether he's young or not young. So what I'm telling is, if the age of the person is between 17, it's a 12 to 50, then he is called as a young man. And if it is not, either less than 12, he's a child. If greater than 50, he's an old man. So what we can do is that we can just change this variable name to age, and we will receive age from user. And what we have to check, the same thing, I'll change. Age should be greater than or equal to 12, and it should be less than or equal to 50. And if this condition is true, I can say that he is a young person. So young. Suppose if this condition is not true, I can say that he is not young. So I can say that he is not young. Okay, so we'll again go for the compilation and we will check whether this is working or not. Sorry, it is not hour, it is age. We have given a wrong variable actually. Yes. So again, if you execute, it is asking. So I can give, for example, 2 months not young, 11 not young, but for example 34 is a young boy, and if it is 67, then it is not young. So it is working as we expect. Yes. What's the next thing that we can do? We will just go with nested if. We'll use nested if, like if else if. We'll go with nested if. Okay, so what is the scenario that we are going to do to demonstrate nested if? The first thing that we are going to do is maximum of 3 numbers. Maximum of 3 numbers. Okay, so for example, let us take A equal to some number called, for example, 10, and then B is equal to some number called 28, and C is equal to a number called 13, for example. And if you see the maximum of these 3 numbers, the maximum is 28. And how to find it programmatically? First of all, what I can do is that I can check whether A is first of all greater than B or not. If A is greater than B, it is not enough information to tell that A is the greatest among the 3 numbers. You have to also verify that whether A is also greater than C. So you will have one more condition, which is A is greater than C also. So these both conditions, so 2 conditions are coming. When 2 conditions are coming, what I told you, you have to use the logical operator to make it a compound conditional statement. How to combine these two? I think both, I told you that both these conditions have to be true. Both conditions have to be true means I have to use logical and when these 2 conditions are true, then I can say that definitely A is a bigger number. If any one of this condition is not true, then definitely A is not a greater number, and the competition is now between B and C. And now if this condition is not true, you cannot directly go for the else part, because you have one more condition separately. That condition is either you have to check whether B is greater than C or not, because the A is out of the game. Because if this condition is false, if this A greater than B and A greater than C, if this condition is false, then definitely A is out of the game, so it cannot be the greater number. So the competition will be between B and C. That is why I'm just comparing B and C. If B is greater than C, then now B will become the greater element. Suppose if both these conditions are false, if this condition is also false and if this condition is also false, then automatically C becomes a greater element. That is what we are going to do now. So for example, I will take num1, num2 and num3. I will use a scanf function to receive 3 integers like %d, %d, followed by ampersand num1, comma ampersand num2, comma ampersand num3. So now if you check here, what is the first condition that we have seen here? The first number has to be greater than the second number at the same time, and the first number has to be also greater than num3. 3 also, the third number also. When this condition, this compound condition is true, then only I can say that number 1 is greater. So if this condition is true, we can print that percentage D is the greatest element, is the greatest element. And instead of percentage D, what I need to give, I have to give number 1, because number 1 is the number 1 is the greatest element. Then I cannot go for else. Again, inside else, I need to give one more if. So I will give you two ways of writing it. So inside else, what I will do is, if this condition is not true, I will enter into this else condition and I will check whether if num2 is greater than num3, as we discussed. So if this condition is not true, then I will check whether the second number is greater than third number or not. If second number is greater than third number, then I can say that number 2 is the greatest element. So I can say that percentage D is the greatest element, comma num2. Suppose if this condition is not true, make one more else condition. Suppose if this if condition is not true, then you can print that the last option is, if A is also not greatest, if B is also not greatest, definitely you have to go with C. So num1 is not greatest, num2 is not greatest, so you can say that percentage D is the greatest element, and you can say that num3 is the greatest element. Yes, fine. So this is a way of writing this. So this becomes a nested if. Why? Because inside if else statement itself, you are introducing one more if. So you are making nested, you are making this if condition nested. So this is called as nested if. So in order to make it very simple, we have a statement called else if. So instead of writing like this, what I will write is, instead of writing a if statement inside else, you can write directly here itself else if. Inside else you are writing if. Instead of that, what you do, after else you write if and convert it into else if. So inside, it is similar to writing a if statement inside a else part. So else if, what you need to check, num2 is greater than num3. If num1 is not a greater element, then either num2 or num3 has to be the greater element. So I'm checking num2 is greater than 3. So if this condition is true, then I will write inside this else if block that percentage D is the greatest element. It is the greatest element. Now, okay, so instead of percentage D, I can give num2. What's the else part actually? Else part is that the remaining element num3 is the greatest element. So it becomes percentage D is the greatest element, and it is actually num3. Okay, so this is also a fine way of writing it. I think this is better than the last one we write, because this is equal, this is literally smaller in size also, codes are less, at the same time this looks readable also, this is not complex. So we can just go for the execution and we will check whether this is working or not. So we will just go for compilation, and now what I have to give is that I will just give 10 the same number, 10, 28 and 13. I will just give 28 is the greatest element. I'll just change the order, 67, 21, 45, 67. Okay, again one more compilation we will do. We will do 1, 5 and 78. Yes, 78 is the greatest element. So this is performing in the right way. Okay, so the procedure is perfect. Fine. So what is the next thing that we are going to do is, we will be finding the nature of the roots of quadratic equation. This is a little different, right? So we are going to find the nature of the quadratic equation. So we will see it. So yesterday itself we have seen the root formula of the quadratic equation. So what is the root formula for? So what we are going to find is, we are going to find the nature of the, we are going to find the nature of the roots of, not quadratic equation, we are going to find the nature of the roots of quadratic equation. So first of all, to find the nature of the roots of a quadratic equation, first of all I will write the formula for finding the roots. First of all, what is a quadratic equation? A quadratic equation is in the form of ax square plus bx then plus c. This is equal to 0. This is what a quadratic equation, a solvable quadratic equation. Ax square plus bx plus c. So if the highest degree is 2, then it is called as quadratic equation. How to find the values of x, the roots of x? How to find? You have to find by using the formula. So root is equal to minus b. You know this formula, right? Minus b plus or minus followed by square root of b square minus 4ac and the whole divided by. Okay, it's not only for square root, it is whole divided by 2a. This was a formula, right? So what we are going to do is we are going to say the nature of the roots. How we are going to say? There are three nature, but what we will do is to find the nature, let me take only this b square minus ac, 4ac. So I will just take b square minus 4ac alone. So I will just take d is equal to b square minus 4ac. I'm taking only this square root part. I'm not taking square root, I'm taking the inner part of the square root. B square minus 4ac. Okay, so I'll just tell you one thing. Let me consider that the d becomes 0. Let me consider that d becomes 0. If d becomes 0, what will happen? The entire square root part will become 0 because square root of 0 is again going to be 0. Okay, so then it is 0 means if this part is 0, if you see, let b be anything. Let b value be anything. If it is anything, anything plus 0 again the same number. Am I right? Anything plus 0 will be again the same number. So plus or minus is not going to do any effect. So for example, let me consider that b is like 5. So minus 5 plus or minus 0 is going to take again 0 only. Plus also 0. If you do plus operation also 0. If you do minus operation also 0. So what you can say, two roots, the plus and minus, two roots will be same. If d is equal to 0, you can say that first of all the roots are real. Okay, you can say that the roots are real, and at the same time you can say that they are same. The roots are same, like you can say that the right terminology will be equal. They are equal. So if this b square minus 4ac, that the d part is 0, then this will not affect the root. And if you do plus addition also, if you do subtraction also, both will have the equal root. So if d is equal to 0, you can say that the roots are real and they are also equal. And then I will come to the next classification. Let us check that if d is greater than 0, what will happen? If d is greater than 0, for example, it might be 5 or 6. For example, let me consider that this b square minus 4ac is 36. If it is 36, what will happen? Square root of 36 will make it 6. Then this number will be there. So 6 will be added and subtracted from some number. For example, let me take again 5. So if 6 is added with the 5, then it becomes, if 6 is added with the 5 minus 5, then it becomes a positive 1. Then it becomes a positive 1 if it is added. Suppose if it is subtracted, what will happen? It will become minus 11. So you get two different value, and these two different values will be divided by 2a. That is the next one. But you have a different root. So if this part is 0, then you have the equal root. Two roots will be equal. And if it is d is greater than 0, what you can say is roots are real. Roots are real, but at the same time they are not equal. They are different. So they are not equal. They're not equal. Yes. The next thing I will tell you is that if d is less than 1, sorry, less than 0, if d is less than 0, what will happen? If d is less than 0, it means negative number. If this square root of is a negative number, what will happen? If it's a square root of minus 1, square root of minus 2, square root of minus 3, square root of minus 4, what will happen? You know very well that square root of a negative number will be an imaginary unit. It will be an imaginary part. It will not be a real part. So if d is less than 0, what you can say is that the roots are not real. The roots are imaginary. That's it. So we have taken a quadratic equation, and we have taken the formula to find the root of a quadratic equation, and we have taken this only the square root part as a d, and we check if d is equal to 0, we say that roots are real and they are equal also. Roots are equal if this is 0. and if d is greater than 0, then the roots are real. At the same time, they are not equal, they are different, like here. Suppose if d is less than 0, then the root becomes imaginary, it is not even real number itself. So using all this, with the help of these conditions, shall we write a code actually? Yes. What is the input you require? I require b, I require I think I require abc, because using abc only I can produce this formula, then assign it to d and check for these conditions. So first of all, what I will do is I'll take 4 variables, integer a, b, c, and also followed by d to store the answers. So using scanf, I will just receive the values of a, b, c. So scanf percentage a, sorry, percentage d, percentage d, percentage d, followed by ampersand a, ampersand b, and ampersand c. So now what I will do is I'll just calculate this b square minus 4ac part. So d is equal to what I can do is b square. What is b square? B square means b multiplied by b, then followed by minus, I can write 4 multiplied by a multiplied by c. I think we had already a separate session for expression, how to write expression, and we are following the same methodology here. Is it right? Yes, it is perfectly right. We don't need any brackets to come here. The associativity and the precedence, everything is fine here in the equation. So after calculating this thing, what you can say, you can write a condition. For example, if d is equal to 0, what you can say, if d is equal to 0, you can say that roots are real and they are equal. So printf roots are real and they are not equal. They are not equal. Sorry, they are equal. Sorry, they are equal. So you can remove not. So roots are real and they are equal. We'll just go to next one. What is the next thing that I can write? Nested if. So instead of writing else inside if, you can write else if. So else, I'm checking another if condition. What if condition I will check? If d is greater than 0. If d is greater than 0, what it determines? If d is greater than 0, it means that the roots are real and they are not equal. So what you do, you write a printf statement by telling that the roots are real and they are not equal. They are not equal. And finally, only one more condition is there. I think that you can again write else if condition, or you can directly write else, because if these two conditions are not true, definitely that is the only remaining condition. If d equal to 0 and d greater than 0 is not true, then automatically the number will be a negative number. So you can also write else if condition, no issues. Else if d less than 0, you can write also directly, you can write it inside the else function. What you can write in the else condition, actually you can write printf roots are imaginary. Roots are imaginary. Yes, fine. So we'll just execute this and we will see what it is going to give us. So we'll give values for a, b, c, actually 1, 3, 5. Roots are imaginary. Why the roots are imaginary? A value is 1. So first of all, b square. What is b square? 3 square 9. 9 minus 4 into 1 multiplied by 5, 20. So it is like 9 minus 20, it becomes a negative value. Negative value means imaginary part is, it's the imaginary part, roots are imaginary. So it's working fine. So we can give one more example and we can check. For example, let me reverse it and give 5, 3, 1. Again, it's imaginary. Okay, we will give 3, 5, and 1. This is giving you roots are real and they are not equal. The roots are real and they are not equal. How will I say that? How can I make it a 0 value? How can I make it a 0? So b square also have to be 0, 4ac also have to be 0. So what I can give, actually, what I can give is ac I can give 1 and b I can give 2. It means that 2 square is 4 minus 4 into 1 multiplied by 1, again 4. 4 minus 4, it will be 0. So what I can give is a value can be 1 and b value can be 2 and the c value can be 1. Roots are real and they are equal. So it is perfectly working. So we have seen how to find the nature of a roots of the quadratic equation. Yes. So next thing is that we can see So I think like this you can write lot of examples. For example, if you want to if you are having 7 days in a week and you want to find whether which day you are, okay, for example, if input will be given either 1, 2, 3 or 4. If the input is 1, you have to say Sunday. If the input is 2, you have to say Monday. So if such a code is given, what you have to write? You have to write 7 if else if ladder and nested if else if ladder, and you have to write if day equal to 1, printf Sunday, day equal to 2, printf Monday. So in the similar pattern you have to follow, and you have to do all these things. The next important thing that I will be telling you is, I'll just tell you about short circuit. I'll tell you about short circuit. And what is short circuit is? Short circuit is a part of if condition only. Okay, we will see about short circuit. For example, you used to give a condition, right? For example, if a number has to be between the range of 10 to 30, if you have to check whether the number is between 10 to 30, what you will do? You will check if the number, some number n, variable n, if it is greater than or equal to 10, and at the same time you will say that the n has to be also less than or equal to 30. So now if you see this first condition, so n value, we will assume some n value, for example it is 10. Okay, n value is equal to 15. So now tell me, what I will do is, I'll just go and check here for n greater than or equal to 10. Yes, n is greater than or equal to 10. So this is true. So when this is true, I think for AND gate, I think both these things have to be true. So since this is true, I will just go for this condition and I will check this n less than or equal to 30. This is also true for n, so it will be executed. Suppose if this n is equal to 8, what will happen? So you will check the condition n greater than or equal to 10. So 8 is greater than, so when 8 is greater than or equal to 10 is checked, the condition becomes false. When the first condition becomes false, short circuit will happen, so the execution will stop here itself, because when you are using AND gate, one of your condition have become false. There is no need of checking the other condition itself. So when this condition becomes false, what will happen? It will not go to this right hand side itself. So short circuit will happen and the process will stop on the left side itself. Okay, so we will just I'll just change this n is equal to 15 itself, and I'll just change this AND gate and logical operator to OR logical operator. Now tell me, what is this? N is greater than or equal to 10. For n is 15. Yes, the condition is true. When this condition is true, what will happen? Short circuit will happen, because according to OR gate, either one of the thing have to be true. If either one of the condition is true, then if this is true, I know there is no need of checking this, because at least one condition is already true. So when the first condition is true, it will not go to the right side part itself. Short circuit will happen coming to the OR gate. Okay, fine. So suppose why I'm telling you is that some people used to write like this: n greater than or equal to 10, and n or plus n, some condition plus n is equal to greater than is less than 30, like this. So when what happened, when the first condition is true, it will not come here itself. When it is not coming here, this plus n will not work. Actually, this might be a procedure. This might be a very important process in the procedure. So when an important process is there, don't write it in the condition. Don't write it in the compound condition. Okay, because this might not work sometimes. Sometimes short circuit will happen based on the problem, based on the input. Okay, so this is what called as short circuit. Hope you understand what is short circuit. Yes. And now I will just show you a part called dynamic declaration. What is dynamic declaration? Just I'll show you what is dynamic declaration. In the meantime, just I'll take all these things. So I'll just show you what is dynamic declaration. And the dynamic declaration, for example, I'm just declaring a comma b comma c, for example, and let me assign a with 2 and b with 5 and c with 10, let me assume. And now what I do is that I write a if condition. Just let me make a condition. I will just write if b is greater than a. If b is greater than a, then what I need to do is a is equal to b. So if the second number is greater than the first number, then change the first number into second number. So since 5 is greater than 2, I will change a also into 5. That is what the process. Okay, so but what I am going to do is I'm introducing a new variable. I'm declaring a new variable inside if condition. I'm not declaring it outside. I'm declaring inside the if condition. And if I declare it inside if condition, and what I'm doing is that I'm just taking this I'm just instead of assigning b to a, I'm assigning c to b. Actually, I'm assigning c to b, and after assigning b to c, and I will be printing the value of c, variable called c. And I do this printing statement both inside and outside the if condition also. I'll just print the C. So what you have done, you have taken three variables a, b, c, and sorry, it is not c because outside also you are having c, right? So what you do is take the new variables at d and just print d, and outside also just print d. So now what will happen? Just you can go and just execute and just check what is going to happen. So compilation is throwing an error that d is undeclared. What's the reason? D is undeclared because you are declaring the variable inside this if condition. So what will happen is once this if condition block is closed, then this memory block will be deallocated automatically. The memory that is allocated for the variable d will be automatically deallocated when it is seeing this close curly braces. So automatically outside the if block there might be no variable called d. This I will just show you a demo here by just doing this doing a debugging process here. So what I will do is I'll just convert this into a breakpoint, and I'll just convert this. So what I'll do is, since there is an error, I'll just take this printf statement out, and I'll just write outside. I'll just write printf %d comma. I'll just print the value of c just for the sake of demo. For the sake of demo, I'll just print %d comma c. Fine. So now what I will do is I'll start the debugging process, line by line execution process. From third line, I'll just start this debugging process. Yes, the debugging process is started. I think in the previous videos itself I told you that the compilation starts from the main function whenever a main block is invoked. Whenever the main block is starting its execution, a corresponding activation area will be created in the stack memory. Stack memory means RAM memory. Okay, so after creating an activation area, what will happen? Whatever the variables which is required inside that block will be created inside this stack activation area only. So inside main activation area, if you see, by default it is taking ABC, but the garbage values are there. Don't see that is 040. It's a garbage value. Now what I will do, I will execute fifth line. If I execute fifth line, automatically the values becomes 2, 5, 10. But so far, if you see in the main function, there is no variable called d is there, because till now you have not declared it, so it is not coming in the game. So now I'm checking for the if condition. If this if condition is true, I will enter. So I think this if condition is true because b value is 5 and a value is 2. So this if condition is perfectly true, so it will enter inside. Once it is entering inside, now what happens is there is a new variable called d, and it is having a it's having a garbage value. Don't think that this is the 5. Okay, so this d value is assigned with the random value. So now I will execute this d equal to b. So automatic 5 value 5 will be just allocated, 5 will be assigned to d, and now what I will do, I will just print the value of d. And once I come out the if, now if you see that variable d is not found, because once it enters into if, this variable is allocated memory with, and once it is coming out of this if it is seeing this close curly braces, automatically the memory allocated to this d is deallocated. So when you come out, you cannot print d. This is what we call it as local variable, actually the scope. But this is what is the background process that is happening inside the compiler. That is what I'm showing you, the inside part of the compiler. Okay, so this is called as the dynamic declaration part. Dynamic declaration: whenever you declare a variable inside a block, that variable will be deallocated when it is coming out of that particular block. Okay, so hope you understand about this dynamic declaration part also. Yes, So what we will do next is we will see about switch case. Okay, we will see about switch case. That's the next thing that we will be doing. So the next concept we will be seeing is switch case, as I am telling now. So now what we will be doing is this. Let me take all these things off and we will start. So now what is the usage of switch case? Switch case will be used to write a menu driven program. So it is it is used to write a menu driven program. When you want a switch, you want a switch whenever you want to write a menu driven program. We will see one example of what is a menu driven program is. For example, there are 7 days in a week, and what I'll tell you is that I'm going to take an integer variable called day, and using scanf I will receive an integer value from user for the and store it in the variable called the day. And now what I will do is, if this day is equal to 1, if the user is entering day 1, then it is a Monday, it refers to Monday. And case 2, if it is equal to if it is 2, the number is 2, then it is referring to Tuesday. It is 3 Wednesday, 4 Thursday, Friday, Saturday and Sunday. In this order I'm going to follow. So you can write also if statement, but this is like a menu driven program. If this is first case, you do this, case 2 do this, case 3 do this. So when it is like a menu driven, a classification is provided, then you can go with this switch statement, switch condition. So first of all, what I need to give us the protocol is that switch is the keyword and followed by a parenthesis. Inside this parenthesis you have to pass the variable that is going to store either an integer or a character. Apart from that, you cannot use anything. It means that only integral data type has to be used. You can go to the previous video where I have discussed about data type. You can see what is integral data type. Integral data type are the data type which stores whole number. Two integral data type are there, which is integer and character. So inside a switch only you can pass an integer value or a character value. So integral data type can be only used. So I'm passing integral data type called a day, and I'm opening a block, open curly braces, close curly braces, inside which I'm going to give case 1, which means that if the day is equal to 1, if the day is equal to 1, so when the variable has to be either integer or character, this case also will be either integer or character only. So case 1, what I will be doing is I will print that it is Monday. I'll just print that it is Monday. Okay, then I'll just write case 2. What is case 2? Case 2 means it is going to be Tuesday. So let me copy this and just let me change only the week. Okay, so now what I will do is just I'll change this to Tuesday. Now what I will do is I'll just copy this case and I'll just do it for some more times. Okay, so case 3, and let me give instead of case 3 I will give Wednesday, and coming to case 4, let me give Thursday. Let me give Thursday. And coming here to the 5th case, I can give, for example, Friday. Coming here to case 6, we can go with Saturday. And here coming to case 7, we can go with Sunday. Yes, this is it. So what will happen is whenever the day input is 1, it will print Monday. If it is case 2, print Tuesday. Case 3, print not only one printf can happen. Inside case 1 you can write multiple statement. So a set of instruction you can perform if the day is 1. It's not only for displaying something, you can perform some instruction here. So any number of line can be given. Okay, so write case 1, you write any number of lines you want, then case 2, any number of lines you want. But one more thing is there's something called as control statement. Control statement, break and continue or two control statement. I will just tell you about break here. Break, what does break mean? Suppose if this case is true, and if you have done all the instruction which is written inside this case 1, you can stop. If you're not writing this break statement, break means you have to stop the process here itself. Okay, so if this break is not provided, then if the case 1 is true, then it will write like it's a pipe, like a pipe. What it will do is it fall. If case 1 is true, case 2, case 3, case 4, case 5, all the cases which is below the true case will be executed. If case 3 is a true, case 1, case 2 will not be executed, but case 3, case 4, case 5, case 6, case 7 will be executed if only case 3 is true. Suppose if case 5 is true, then 5, 6, 7 will be executed. So without giving break, what will happen? It is like a pipe. If you fall, it will go and visit all the cases which is downside to it. So this break is going to be very important part here in the switch. So I have to give break statement everywhere in each and every case. Some situation you might also not require break because you wanted to print all the cases. If you want, you can also ignore the break, but if you ignore break, what will happen? Suppose if case 3 is true, what will do? Case 3 also will be executed, case 4, case 5, case 6, case 7 also will be executed. So I'll just give the break statement in all the cases. And finally, one more thing that we can write is a default section. What is this default actually? Default means suppose if none of the cases is true, then automatically this default will be done. What I can do is then default part is I can write that the input is a invalid input. Because invalid input means it is between 1 and 7 only, it is a valid input. If it is not 1 to 7, then I can say that it is invalid input. This default you can write anywhere, not only at the last. You can write in between, you can write first also, but wherever you write, first of all it will check all the case, then only the flow, the control will be given to default. Okay, fine. So now what I will do is I will just execute this program and we will check what is going to happen. So let me go here to the terminal itself. Fine, so we will just go with the execution of conditional file. 1 minute. Okay, so now I'll just go with the execution of it. Compilation is over. So now what I can give is I'll just give 2 means it is printing Tuesday, 3 Wednesday, 4 Thursday. It's printing quite well. Let me give an invalid input like 0. Then it is going to the default section and is printing. So what we will do is let me take the break section of this 3. If I take the break section of the case 3 and what is case, so what I will give is again I will compile and what I will give is I'll give 3. If 3 is given, what I told you, if break is not there, then the subsequent next case also will be executed, but you find a break here, so it will stop here. So Wednesday, Thursday, both these things will be printed. Wednesday, Thursday, both these things will be printed. So until it find once it is true, it will enter into the pipe and will start traveling inside the pipe until it find a break. If it find a break, it will come out of the pipe, or else it will go and visit all the cases if the break is not there. Okay, I think hope you understand this now, right? So this is about switch case. We will just finish the we'll finish this switch case and we will move next to one more thing. We are going to find whether a given year is a leap year or not by using the conditional statement. Okay, but why I'm just doing it at the last is leap year is very simple. Why you are doing it last? No, I'm going to tell you the entire story behind this leap year. We will be seeing a very big story that is behind this leap year scenes. So what I will do better is, first of all, I'll just tell you about this leap year. What I need to tell you about the leap year. There was 2 major calendars was available. One is Julian calendar. One was Julian calendar, which was made by Julius Caesar, the Greek king. You know about Julius Caesar. You could have read the story about Julius Caesar. So Julian calendar. One more calendar is Gregorian calendar, which is found by one more king called Gregorian calendar. And what I need to tell you about these 2 calendars is that Julian said that there's a big story. Julian said that Earth will take 365.25 days. 365.25 days to complete a single rotation around the sun. That is what called as 1 year. When a Earth is revolving around the sun and it is completing one complete rotation, then it is called as 1 year. So what Julian is telling is that 365.25 days Earth takes to revolve. Okay, so with this what he is doing is that he is making a calendar, and using this calendar they are following. So because of the reason that, for example, in 4 years what will happen, in 4 years, your fourth year, what will first year you will be having 365.25 days. So how many extra days you are having? You are having 1 day extra. 25 days extra you are having, but our calendar is only of 365 days only. So 25 minutes we are losing. See, our calendar is having only 365 days. This 0.25 days is there, right? This 0.25 days we are losing. Yes, we are losing this 0.25. So what will happen? 4 years, what will happen? First year extra 0.25. Second year extra 0.25. Third year extra 0.25. Fourth year extra 0.25. So what will happen after 4 years? It will cluster to give you 1 day, because 4 into 0.25 will give you 1. So for every 4 year, 1 extra day we are spending useless, we are not consuming it. Okay, so in order to use that extra 1 day, what we are doing is that for every 4 year we are adding 1 extra day. That is what called as leap year, which is included in February. Okay, so for every 4 year this 1 day is going to be missed. So in order to not miss that 1 day, what we are doing, we are increasing the number of days by 1 for every 4 years. The story does not stop there. We does not say that we does not say that leap year is only for every 4 years. No, the condition is very different. We will see the further story also. So what happened is that this is what the system that everybody was following all over the world until a certain period. But suddenly what happened is Gregorian said that, he said a different thing. It is not 365 days 0.25, it is 365.242190,949 days will be taken. So he was very accurate. He is not approximately taking it as 0.25, he is taking exactly as the decimal point, 242190,949 days. You might wonder, what is the difference? Yeah, there is a great difference here. So if you see this, what is the difference between this Julian calendar and Gregorian calendar is that in Julian we were using some extra days. See here, we were using some extra days. How we are using extra days? We are using ANS is equal to the difference between the Gregorian calendar and Julian calendar. When you subtract this 365.25 from if you subtract 365.24, this long number, from 365.25, then you will get 0.00780905059. It's a very long number. This much day, what you are doing is you are using extra. So what you should do, you should not use any extra days. You have to reduce the number of days you are going to work, you are going to use. For that reason, what happened is, actually, see, this Julian calendar was started from 325 AD, unknown domini. Okay, it was started, followed by the entire world from 325 unknown domini year to 1752 unknown domini. So how much year they were using it? Subtract both these years. So when you subtract both these things, you will get 1427. So for 1427 years they were using this Julian calendar, by which what they have done is, if you in 1 year, if you see 1 year, you are utilizing this much extra day. So in 1427 days, how many extra days you will be using? Multiply that. Okay, 0.00780905059. and 0.59. So when I multiply this, you get approximately 11. It means that in all these years, in all these 1427 years, 11 days was extra. They have consumed it extra. Since they have consumed 11 days extra, what they have planned is, suddenly what the world planned is that if this keeps on going, then the later period of the world, there will be a big problem in the calendar. So in order to stop the problem which is followed by the Julian calendar, what they did is, actually this problem was happening exactly at September 2 September 2 1752 only this problem was raised. In 1752 only this problem was raised. September 2 is actually Wednesday. So what they did is, actually from September 3 to September 3 to September 13, totally 11 days. From September 3 to September 13, what they did is, they asked the entire world people to lock down inside their home itself, because they wanted to no history to occur in these 11 days, because this 11 days should not be there in the history itself. So what they does is they removed 11 days from the calendar, from the month called September in the year 1752. In the year 1752, in the September month, what they did, they removed 11 days from the month in order to make it compensate. So 11 days extra I used, those extra used 11 days have been removed from the calendar from September 3 to September 30. Yes, fine. So now if you see here, okay, fine. So now one more thing that I need to convey is that we said that a single rotation, Earth will take 365.24287. I'll just take it like this, okay, 24, or we will just take it extra 24, not it is not 387, it is 24219, okay, 24219. Okay, you can see here in the Gregorian calendar, this is now the new refined day. So if you see, I told you that you missed some time, right? Because you calculated leap year by using 365 by 0.25 days, but now you are having only 365.24219 days only. So now what you have to do, leap year system also you have to change. So Gregorian, what he did is he's also changing the leap year system also. How? So what happened is, I told you that this much extra day you consume in every day. So this much extra day means it is actually equal to, every year you will be consuming 5 hours. Every year you will be consuming 5 hours, 48 minutes and 46 seconds. This much hours, what we are doing is that we are using it extra. So in order to reduce this, what we are doing is that we are taking 4 years. For 4 years only we have a leap year, right? For 4 years what happens is, 4 years, 48 minutes. First year we will have extra 5 hours, 48 minutes, 46 seconds. The next year also we will have the same extra 5 hours, and the next year, third year also I will have the same thing. Fourth year also I will have the same thing. After 4 years, if you see the total hours, it is equal to 23 hours and 15 minutes and 4 seconds actually. So they are leaving this 4 seconds and they are taking it as 23 hours 15 minutes. So this is not equal to 24 hours, so it is not equal to 1 day. What we are happening is 45 minute shortage. 45 minute shortage is happening. So when 45 minute shortage is happening, what to do now? So if you see here, see, for every 4 years, one leap year was the previous system. So what they did is they took 100 years, and in 100 years, if you see, for every 4 years, one leap year. So you can say that totally 25 leap years will be there. 25 leap years will be there, and if you see the 100 year, totally 75 normal years will be there. So 25 leap years and 75 normal years will be there. So if you take this 25 leap year and you have that extra 45 minutes, right, lagging 45 minutes. So what you do is you can just multiply 45 multiplied by 24. I will do 24. I'm not doing 25, but I'm doing 24. If I do multiply it by 24, I will get 18 hours. 18 hours. The remaining 6 hours we will handle it later, but now we are having 18 hours extra. So if 18 hours is taken, so what you have to do is, 1 day I'm going to cut. What 1 day? The 25th leap year is there, right? For every 100 years, the 25th leap year. The 25th leap year I will just remove and I will make it 24 leap year. So what will happen? Every 100th year will not be a leap year hereafter. So that is the reason why 1900 is not a leap year, because it is divisible by 100. Because for every 100 year, there will be no leap year at all. So 1900, 2000 and 2100, they are all not leap years. So the reason is, extra 45 minutes we have taken, right? That extra 45 minutes will become 18 hours by the 24th leap year of 100 years. So the 25th leap year, which means that 100th century, what we have, the 100th century means 900th century, 2000 century, 2100 century, 2200. All these things we consider it is not a leap year. We are removing from the leap year. So now, okay, fine. So 18 hours have been handled. Fine. Now, what is the remaining hours? 6 hours. So if you take 6 hours, what will happen? For every 100 years, for every 100 years, you have an extra 6 hours. For every 100 years, sorry, your 6 hours is missing. For every 100 years you're missing a 6 hour. So that what will happen is, first year 6 hours, second year 6 hours, third 100 year, see, first 100 6 hours, second 100 6 hours, third 100, and fourth 100. So when 400 years, for every 400 years you will have, for every 400 years you will have 24 hours. You will be taking 24 hours extra for every 400 years. So what we can do, 24 hours, sorry, 24 hours is missing. When this 24 hours is missing, we have to use it. How we can use it? For every 400 years you include one more leap year. So what I can say is that if a year is divisible by 4, you cannot directly say it is a leap year, because sometimes it might be also divisible by 100. If it is divisible by 100, we told that it is not a leap year, because only 24 leap year we are taking. 25th leap year we are removing. So year has to be divisible by 400 is one condition, and year, the same year, if it which is divisible by 4, should not be divisible by 100. So it should not be divisible by 100. So year should be divisible by 4, and year should be not divisible by 100, or otherwise. Either these two conditions have to be true, or a solo condition, which is either the year divisible by 400, because for every 400 years 24 hours is missing. That 24 hours I will just use a one extra day as a leap year. So for every 400 years I will get one leap year. So this is a big story behind the leap year. So now, using all this story, what we will write is, we will write a condition, we will write a program to find the leap year. We will find the, so first of all, we will take a variable called year, and we will just receive it from the user. So scan of %d comma ampersand year. And now what I will do is, if year mod, okay, if year mod 4 equal to 0, so it is divisible by 4. And one more condition is year mod 100 not equal to 0. So these are two conditions. You have to make a compound conditional statement. So you mean you have to join this two condition by using a logical operator. What's the logical operator? Both these things have to be true. It has to be also divisible by 4. At the same time, it should be also not divisible by 100. Okay. So when this condition is true, one more option is given, or either these two conditions has to be true, or otherwise the year should be divisible by directly 400. Why I'm checking it 400? Because if it is 400, definitely it will be divisible by 4. Okay, so I'm checking whether it is divisible by 400 or not. If this condition, any one condition, either this complete compound conditional statement or this condition, either one is true, then I can say that it is definitely a leap year. So this is a leap year. Suppose if this condition is not true, then I can say that it is definitely a, it is not a, I can say that it is not a leap year, not a leap year. So we'll just check whether it is working properly or not. I'll just compile it, and then now I'll just execute it. For example, I'll give 1900, which we know that it is not a leap year. Okay, it is not a leap year, but it is telling me that it is a leap year. So what you can say, actually, you have to say it is not R, because it is not R, I think so, because when this is false, okay, this is a leap year it is showing. Why this is showing as a leap year? Can you just justify this? Fine. So if you see here, it is divisible by 4. Yes, it is divisible by 4. but it is not divisible by 0. So I think this condition will give you a false, am I right? Because this is divisible by 100. So when this is divisible by 100, this will give you false. So when this is false and this is true, the entire part will give you false. And R, this here is not divisible by 400. This is divisible not by 400. So this is also. So when both are false, then I have to go for the else part, right? So how if part is working? We have to verify. Is there any mistake that we are doing here? Is there any mistake? So if you see here, we have not given equal to equal to, we have not given any relational operator here. That was a problem here. Okay, so here mod 400, we have to give that it is equal to 0, mean divisible, right? So when we give this, and we will again try that same compilation, and then we will see, we will check by executing it. No, it's not expression. I have just compiled a different file. It is conditional, and I'll just execute hello, and I'll just give 1900 again. That's a not really leap year. Yes, that was one mistake, that we have not given this equal to conditional. That was a mistake. That is why the wrong output was given. So 1900. So if I give to go to 2000. 2000 is a leap year. 2000 is a leap year because it is divisible by 400. So it is a leap year. So I think, hope you understand the story, everything and all. Okay. So this missing time only, what they are doing for every 4 year also they are doing. 100th year they are reducing it. They are not taking it as a leap year, and 400th year they are taking it a leap year. So for every 4 year you get, at the same time every 100th year you don't have a leap year, and at the same time for every 400 year also you have a leap year. Okay, fine. So this is it for the session, and in the next session what we will do is we'll start with looping, and we will see number crunching and a lot of many problems related to basic problems related to looping also we will see in the next lecture. Okay, so before I conclude this session, I just want to show you the myslate.6phrase.com portal, and we have many courses available here. So if you want to take any course, you can just purchase this, and you can practice this problem sets actually. So we have several courses, and these courses are well organized courses. So I'll recommend you to purchase any of your if you are having learning plan, either C you have to learn data structure, or Java or Python, or for any specific company you want to prepare. So respective courses you just purchase, and you can just go ahead with the practice. Okay, so thank you, and this is it for the session. Thank you.